Yeah, hello, you're welcome to our class in logarithm. And in logarithm, we shall be looking at the rules of logarithm. So, rule 1, we have the multiplication rule. In the multiplication rule, if you have log AP times Q, what does it mean? It means log AP plus log AQ. So the multiplication has been separated into two. So we have log AP plus log AQ. Number 2, we have the division rule. For the division rule, let's take this again. If we have log AP divided by Q, it becomes log AP minus log AQ. So we have our minus there. Then rule 3, we have what we call the power of logarithm. So if you have P equal to A raised power x, what does this mean? This means log P base A equals to x. If we have log AP raised power n here, what does it mean? It means n multiplied by log AP. So we can see the n here, which is a power, becoming a whole number, which is n log P base A. Number 4, we have the logarithm of unity. When we talk about logarithm of unity, we all know that A raised to power 0 equals to 1. That is any number raised to the power of A. Any number raised to the power of 0 equals to 1. Now this means in logarithm, we can convert to logarithm, it will become log 1 base A is equal to 0. We shall look at the application of all these rules shortly. Now, as the logarithm of unity, then we have the logarithm of base. For that, if we have A raised to power 1, it's the same thing as A. So with this, we can say that log A base A is equal to 1. So all this can be applied. Okay, then we can change the base of a logarithm. How do you change the base of logarithm? For instance, if you have log P base A equal to x. Originally in indices, what does this stand for? It means A raised to power x equals to P. That is what it means. Alright, so we bring that here, which is A raised to power x equal to P. Let's take the logarithm of both sides, but this time around, the base of the logarithm will be in base B. So we can have log A raised to power x base B is equal to what? Log P base B. We have the same base over here. Then do not forget the power, whereby x multiplies log A base B, which is log P base B. Hence, head is equal to log P base B over log A base B. Don't forget that we have our log P base A equals to x, so we can replace it as log AP as log P base A is equal to log P base B over log A base B. So we have successfully changed the base of this logarithm. Here we have A here, then we have B and B here. Alright, so let's look at some of the application of the rules of logarithm. Simplify. A, log 4 plus log 3. B, log 16 base 5. C, log 4 base y plus log 64 base y equal to 4. D, log square root of 27 base 3. When you have a question like this and you are not given any base, take note that it is in base 10. Now, since they have a common base, you can easily apply the rule of logarithm. So we have log 4 multiplied by 3, and that gives us what? Log 12. Another example, if you have log 16 base 5. In this case, we are going to apply raising to a given power. So we have log this base 5. This means 2 raised to power 4, and that is 4 log 2 base 5. Let's look at another example where we have log 4 base y plus log 64 base y equal to 4. In this question, okay, we are going to apply the multiplication rule, where we have log y into bracket 4 multiplied by 64 equals to 4. So 4 times 64, that is 256, equal to 4. Converting it into the index form, we will have y raised to power 4 equals equal to 256. So we have y raised to power 4 equal to 4 raised to power 4, because 4 raised to power 4 equals to 256. So since the power are the same, hence y equal to what? Y equals to 4. Okay, so taking this next example, we want to simplify log square root of 27 base 3 to its lowest term. This means the square root here means 27 raised to power 1 over 2. Then we have log 3. At the same time, this also means 3 raised to power 3, all to the power of 1 over 2, because 3 times 3 times 3 gives us 27. So we combine this, we have log 3 to the power of 3 over 2. Using the rule of raising to the power, this 3 over 2 will come to the normal side, which is 3 over 2 log 3. Now let's remember the rule of logarithm of base, where we have log 3. That's if the base and the number are the same, therefore we have 1. So log 3 base 3 equals to 1. So we have 3 over 2 multiplied by 1. So our answer is 3 over 2. So once you solve this next question, which says if log 2 equals 0.3010, log 3 equals 0.4771, and log 5 equals 0.6990, find A, log 36, B, log 25, plus log 9, C, log 1 over 4, D, log 0.125. All of them are in base 10. A says we have log 36. Log 36, the idea to solving this question is to look for the multiples of 2, 3, and 5 that will give the number which is here. So for this, we have 36. What are the numbers that will be multiplied to give 36? We can use log 2 times 2 times 3 times 3, because 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. Now applying the rule now, that's the multiplication rule, where we have log 2 plus log 2 plus log 3 plus log 3. Log 2 is 0.3010, repeated 2 times, so it's more like multiplying by 2. Then log 3 is 0.4771, which is more like multiplying by 2 as well. We will have 0.6020 plus 0.9542. Adding this, that would give 1.5562. The B aspect says we have log 25 plus log 9. So we take this gradually. We have log 25, and that's the same as saying log 5 times 5. Then we have log 9, which is 3 times 3. So we are making use of the logarithm values that we've been provided with. Applying the multiplication rule, log 5 plus log 5 plus log 3 plus log 3. So when we have this, log 5 here is 0.6992 multiplied by 2, since we have 2 of it here. Then we have log 3, which is 0.4771, also multiplied by 2, and that gives 1.3980 plus 1.9542. So when we add this together, we have 3.3522. Alright, so we're looking at the C aspect, where we have log to bracket 1 over 4. Now what does this mean? It means log 4 raised to power minus 1. And we can, so this minus 1 will be brought to the back here. This is, we are applying the raising to power rule. So we have minus 1 multiplied by log 4. And that means minus 1 multiplied by log 2 raised to power 2. Then the 2 comes to the back here. That's minus 1 times 2 log 2. So that's minus 2 multiplied by log 2 is 0.3010. So minus 2 times this gives minus 0.60 And the last under this aspect, we have log 0.125. For us to solve this, let's express it in terms of fraction. So when we move the decimal 3 times, we have 125 over 1000. We have 1 and we have 8. So we have log 1 over 8, which is same thing as log 8 raised power minus 1. So we have minus 1 log 8, and which is minus 1 log 2 raised power 3. Hence we have minus 1 multiplied by 3, because this 3 comes, the power here comes here. Then our log 2 is 0.3010. So we have minus 3 times 0.3010, and that gives minus 0.9030. So that is the final answer. Alright, so we want to solve some more questions. So let's look at this question. We have log y squared base 5 equals to log 3x base 5 plus 2. We have that log 5 y squared equals log 5 3x. If you remember some of our laws of logarithm, we could say that log 525 equals to 2. That is 5 raised power 2 equals to 25. So if you have that log 25 base 5 equals to 2, when we convert it into the index form, we have it as 5 squared equals to 25. So we could replace 2 with log 525. So we'll make it log 525. Now we go like this: log y squared. Following the law of logarithm, since they have the same base here, we'll apply the law, which is that 3x multiplied by 25. Hence, we will have it as log 5y squared equals to log 575x. Since they share the same logarithm and base, this cancels out. So we are going to express y in terms of x. So our answer is y equals to square root of 75x. This is the solution. Now let's take another example here. So we have to solve this question if log 2x plus 1, all in brackets, base 10 minus log 3x minus 2 base 10 equals to 1. We have to look for x. How do we go about this? Let's follow our rule of division, where we have log 10 into brackets 2x plus 1 divided by 3x minus 2. So the minus here has turned into division. Then 1 is the same thing as log 10 is 10. So with this in mind, log 10 can cancel log 10. We are left with 2x plus 1 over 3x minus 2 equals to 10 over 1. So we cross multiply and we shall have 2x plus 1 equals to 10 into brackets 3x minus 2. So we shall have 2x plus 1 equal to 30x minus 20. Then we collect like terms. We have it as 20 plus 1 equal to 30x minus 2x. That is 21 equal to 30x minus this, that's 28x. Now with this, we'll divide both sides by 28. So we have 21 over 28 equal to x. 7 goes here. We have it as 3 over 4. So x equal to 3 over 4. Let's look at the next question. Given that log 256 base x equal to 2, find log 1 over x base 8. Now for us to solve this, we will take this first. According to our rule, we have that x raised to power 2 equal to 256. Now we are going to simplify 256 such that it will have a power of 2. So what number are we going to raise by 2 to get 256? And that is 16 squared. Since the powers are the same, that is 2 and 2, therefore our x equal to 16. We'll now go with this, that log 8 all into bracket 1 over our x will be substituted here as 16. Now from here we would write that log 8 and then the inverse of 16. Let's equate this to y. So if this is y, 8 raised power y equals to 16 raised power minus 1. We would make these two numbers to have a base of 2. So we have 2 raised power 3 2 raised to power 3 is 8, then the y. Then 2 raised to power 4 multiplied by minus 1. Since the bases are the same, we will have it as 3y equal to 4 times minus 1, which is minus 4. So y will be equal to minus 4 over 3. Alright, so let's look at this next question where we have log 81 over log 1 over 3. Now this is quite simple. We have this as, let's make it to have a number of 3 raised to power 4, because 3 raised to power 4 is 81 over 1 over 3 is same thing as saying 3 arc of 1. So we bring this 4 to the other side, which is 4 log 3 over minus 1 log 3. Since they have the same number and the same base, so we can have it as this cancels this. So we are left with 4 divided by minus 1. The answer is minus 4. We shall be solving questions on logarithm using the logarithm table. But before we use the logarithm table, we need to have a good understanding of standard form. Now, if you're given the number 912.4 to change it into logarithm. Now, for you to change this, first, we need to convert it to the standard form. From here, 912 represents the whole number part, the whole number, while 4 is the decimal. Now, if you have to convert this to the standard form, the decimal will move 2 places to the back. Now, if it moves 2 places to the back, it moves to the back because the decimal must be just after the first number. And the first number here is 9. So we shall have it as 9.124. This is the number. So the decimal is now after the first number, which is 9. It will be multiplied by 10 raised to power 2. It's raised to power 2 because it has moved 2 places to the back. So this is it in standard form. If you look at this one, we have 0.002718. And if we are to change this one into standard form, the decimal which is here will move 3 places to the front and it will be after the number 2. So move it 1, 2, 3. Hence we have 2.718 times 10 raised to power minus 3. It is minus because we are moving it to the front and we moved it 3 places, then we have it as raised to power 3. Now, logarithm to base 10 are called common logarithm. If we are to change this into logarithm now, this 2 is referred to as the characteristic, and the characteristic is gotten from the power of 10 here, which is 2 points. Then we will open our logarithm table, and when we check it, we'll check the one that has the logarithm table. We'll find the table there. We'll trace it to where we have 91. Then we'll look at the column which has 2 and we'll trace it down. So we'll meet the column that has 2 with that of 91. And we'll find out that 91 under 2 is 9600. Then we'll check the differences. And the difference of 2 there is still 2. So though it is called difference, but it is an addition that will be done. So when you add it, you have 2 here, you have 0 here, you have 6 here, and you have 9. So this is 9602. So this is the logarithm of 912.4. So just as we said, this 2 is called the characteristic, while this 9 is called the mantissa. Now let's look at this. To change this into logarithm, minus 3 will be written as bar 3. That is the characteristic. Then we'll check 97 and then we'll trace the column of 1. 97, we'll trace the column of 1 down and we'll realize that 27 under 1 gives us 4330. So we'll write it there, 4330, difference 8. So we'll go to the column where differences are and you look for 8. Difference 8 there is 13. So though we say it is difference, but it will be addition. So 3 plus 0 is 3, 4, 3, 4. So we are left with 4343. The logarithm of 0.002718 is bar 3.4343, where bar 3 is the characteristic and 4343 is the mantissa. Alright, so let's look at this question. It says that we should evaluate this, that's 912.4 times 30.42 using logarithm table. So for us to do this, we'll have a table like this where we'll put 912.4 here, then 30.42 here. Now we'll have 912.4. Change it to standard form, the way we've done previously. We'll have it as 9.124 times 10 raised to power 2. So 2 is our characteristic. It will be placed there first. Then we will check 91 under 2 difference 4, and that would give us 9602. So we'll place it there, 9602. And then 30.42. We'll move the decimal one place to the back. So we have 3.042 times 10 raised to power 1. So our characteristics there is 1 point. We will check 30 under 4 difference 2. So 30 under 4 is 4829. Then difference 2 there gives us 3. So when we add it together, we will have 4832. 4832. Under the normal number, we have multiplication on this side. But when we are to solve it using the logarithm, multiplication sign will become addition. So we have to add this. So 2 plus 2, 4, 3, 4, 4, and 4. This is the total. Now we have gotten an answer in logarithm, and it needs to be converted back into the antilog. And the antilog is the opposite of logarithm. The opposite of logarithm is the normal number. So for us to check it, we will go to our antilog table. Then we would locate point 44 under 3, and that gives us 2773. That's 44 under the column of 3. Then we check the difference 4. Difference 4 is 3. We add it, which gives 6772. So we have it as 2776. So we have looked at the mantissa. Then what does this 4 mean when we are coming over here? Now this answer that was gotten here is 2.776. That is the normal standard form. But now that we have 4 as our characteristic, it's going to move the decimal 4 place forward. That is 1, 2, 3, 4. And this space where nothing is, we'll write 0 there. So we have it as 27760. So we have our answer as 27,760. Alright, so we want to evaluate 36.75 times 284.7 divided by 0.002718 using the logarithm table. So to proceed, we have our number and logarithm, draw our table. Then we have 36.75. We convert this to the standard form, which is 36.75, and that becomes 3.675 multiplied by 10 raised to power 1. So we have our 1 as our characteristic. Then we'll look for 36 under 7 difference 5. 36 under 7 gives us 5647. Then difference 5. The difference 5 here is 6. So we'll add it together, and that gives 5653. And then we'll go to 284.7. Now for this 284.7, we would convert it to the normal standard form, and that gives, we'll move it 2 places back. That's 1, 2, and that will give us 2.847 times 10 raised to power 2. So that is it in standard form. So we'll take the 2 and put it here, which is the characteristic. Then we look for 28 under 4 in our logarithm table. 28 under the column 4, and that gives 4533. That is 4533, and difference 7, which gives us 11. So when we add this together, we'll get 4544. Now we have multiplication on the normal column here. Going to the logarithm column, the multiplication becomes addition. So when we add it, we have 79104. Then we have 0.002718. We have to convert this also into the standard form, and that gives, move it 2 places to the front, and that is 2.718 times 10 raised to power minus 3. And so we have now the minus 3 here is taken as bar 3, and then we'll check 27 under 1, that is 4330, and then we have a difference of 8. So check the column 8, the difference is 13. And so when we add it together, that gives us 4343. 4343. Here we have division. We've added this. Now it's time for the division. Now the division here turns to minus when it comes to the logarithm. So 7 minus 3, 4. 9 minus 4 is 5. 1, bring 1 here. So we have 11. We have 11 minus 3, that's 8. We have 9 minus 4, that's 5. We followed 1 from here, so we have 3 left. 3, this, so here we have 3 left here. We've put 1 here already. So 3 minus bar 3 is more like saying minus 3. So we have 3 plus 3, and that is 6. So we'll have our 6 in this place. Now we'll check the anti-log table. The anti-log table, we shall check 58 under column 5. 58 under column 5, and that will give us 3846. 3846. Then difference 4. The difference of 4 is same thing as 4. And then we shall add it together, and that will give us 0583, and that is 3850. So when we've checked this, this is what it gives to us, 3.850. That is the normal standard form. Now we have 6 as a characteristic, and that means we are going to move the decimal 6 places forward. So we move 1, 2, 3, 4, 5, 6. So we'll add 0 to the empty places. So we have 3850000, and that is 3,850,000. Okay, so let's look at this question. Evaluate 0.8432 squared using the table. The only difference here is that we have power of 2. So we do it just like we've been solving it. We have 0.8432. We'll change it to the standard form. That means we'll move it 1 place forward. That gives us bar 1, which is same thing as minus 1. Then we'll check our logarithm table. We'll look for 84 under column 3, and that is 9258. 9258. Difference 2 is 1. So when we add it, that will give us 9259. Here we have it 0.8432 squared. When you have squared under the normal column here, when you come to the logarithm column, it becomes multiplied by 2. So we shall have it as this times 2. So 2 times 9, 18. 2 times 5, 10, 11. Times 2, 4. Times 9, 18. 2 times minus 1, and that is minus 2. So 2 times minus 1 is minus 2. And then we have 1 that we've brought here. So we'll add it to it. So minus 2 plus 1, that gives us minus 1. So we have our bar 1 in this place. So we'll check our anti-log table. We'll look for 0.85 under 1, 7096. Difference 8 gives us 13. So we add it to it, and that gives 9017. So when we have it as this is it in standard form here. But now we have bar 1. That means we are going to move it one place forward. So when we move it one place forward, we have it at 0.7109. So here is our answer. So if you are given this, now we should simplify this logarithm. We have bar 1.3846 divided by 2. We would have been thinking we could divide it straight away, but it's not possible like that. Here is bar 1. So what we need to do here is that 2 can't go straight into bar 1. And bar 1 here is similar to saying minus 1. Similar, but not exactly. Minus 1 is owing, like owing somebody one naira, or whatever the unit. So owing somebody 1 naira. Now we want these two to be a number that this denominator would easily divide it, that it will be divisible easily. So what we can do is to more or less borrow 1 from a place where you've borrowed before. Now if you borrow 1 from here, that means it was originally bar 1. So when you borrow 1 again, it means that we'll be having bar 2. Now that one which you borrowed comes here, and now this is the one that you borrowed. Then you join it with 0.3846 divided by 2. You could combine this back and get your original bar 1.3846. Now 2 can go directly in 2. So 2 into bar 2 is bar 1 plus 2 into 1. This one is a positive characteristic. 2 into 1 is 0. Then 2 into 13, 6, 9, 2, 3. And so we combine the two. We have it as bar 1 plus 0 gives us bar 1.6923. So don't forget that if you have something like this, you can't divide it directly because the characteristic here is negative, and it is not divisible by 2 directly. B. Let's look at more examples. If we have bar 2.456 divided by 5. When we take a good look at this, the characteristic here is bar 2 and the divisor is 5. It won't go easily. So it's more like owing somebody 2 naira before or $2 before, and you go ahead to borrow $3 extra. How much are you owing altogether? That is bar 5. Then the 3 which you borrowed comes here, and then you have 3.456 divided by 5. So 5 would go easily in 5. 5 into 5 here is bar 1. 5 into 3 here is 0. 5 into 34, we have 6, minus 4. 5 times 9 is 45, and 5 here 1. So we have 5 here as well. So 1, then 5 into this is 3. So with this now, we can combine it. We have bar 1 and this. Bar 1 plus 0 gives us bar 1.6913. Let's look at some more examples. If we have bar 3.1248 divided by 2. If we take a close look at this, 2 will not go directly into bar 3. So what we could do is to take 1 from bar 3, and that will leave us with bar 4 plus 1.1248 divided by 2. And that leaves us with 2 into bar 4. That's bar 2 plus 2 into 1, 0. 2 into 11, that's 5. Put 1 here. 2 into 12, that gives 6, 2, 4. So when we add this together, we'll have bar 2.5624. Let's take the last example under this aspect. If we have bar 1.3742 divided by 3. 3 will not go into bar 1. So what we could do here is to borrow 2 from the same bar 1, and that will leave us with bar 3 plus 2.3742 divided by 3. So we have bar 1 plus 3 into 2 is impossible, 0. So 3 into 23, that's 7. Then we put 2, that's 9. 3 into 4, 1. then we have 4. So when we add it together, we will have bar 1 plus 0, that is bar 1.7914. Alright, so we want to solve this question, which is 15.05 times square root of 0.00695 divided by 6.95 times 10 raised to power 2. This looks a bit complicated but simple as well. So we have our number and log here. To solve this, is be good if we have an extra column. We'll soon get to know the reason. So we have 15.05. We'll change this to the logarithm form or to the standard form. We'll move it one place to the back, and that is 1 point. We'll look for 15 under 0 difference 5 in our logarithm table, and that gives 1775. So we have that. Then we have the next one, which is 0.00695. So for this, we would convert it to the standard form, which is you move the decimal 3 places to the front, and that is bar 3. Okay, then we'll look at the logarithm table, look for 69 under 5. That's 8420. Now do not forget that we have the square root of 0.00695. So we'll put it there, 0.00695. So on the normal column here, the square root is square root here, but when it comes to the logarithm column, it becomes divided by 2. So we'll have it as bar 3.8420 divided by 2. So that is what happens to square root when it comes to the logarithm column. Now 2 would not divide by 3 straight away, so we would change it to a number that is divisible by 3 easily. And how is that done? We take 1 away from bar 3, meaning that we have a deficit of bar 4. So the one that was taken away is here, which is 1, and then we have our 0.8420. So if you combine this bar 4 plus 1, you will still get your bar 3 back, divided by 2. So 2 into bar 4 is bar 2, plus 2 into 1 is 0, 2 into 18, that's 9. So here 2, 1, 0. So we combine this, and that will give us bar 2.9210. And so we have all this multiplied, that's 15.05 times 0.00695. So the multiplication here becomes addition here, so we bring this here 1.775. so we have this column so that we have a neater calculation. We add it together, and that gives 5. 7 plus 1 here is 8. 9, 0, 1. So 9 plus 1 is 10, so we write 0, we carry 1. 1 plus 1 here is 2. Then 2, so we have 2 plus minus 2. That is, plus times minus is minus 2. So 2 minus 2, that gives us 0.0985. But we are not done yet. So we come here and we'll continue our calculation, 0.0985. And then we have 6.95 times 10 raised to power 2. The 2 is the characteristic for logarithm, so we'll place that here, 2 points. We'll check 69 under 5 in the logarithm table, and that will give us 8420. So we can bring them together here, 2.8420. So because we have it as divided in the question here, it becomes minus. So we are going to subtract 2.8420 from 0.0985. 5 minus 0 gives 5. 8 minus 2 gives 6. 9 minus 4, that gives 5. 0 minus 8 is impossible. So what we can do is to come to 0 and borrow, although nothing to actually borrow. So we borrow from somewhere there, and the 0 here has a deficit of minus 1. And so the what you borrowed comes here, which is now 10. So 10 minus 8, that's 2. Then we have minus 1 in this place. So minus 1 minus 2. Minus 1 minus 2. And that gives us minus 3. And that's similar as writing bar 3. And so we'll convert this back to the normal, which is by checking the anti-log table. 25 under 6 difference 5 in our anti-log table, and that will give 1805. That's what this will give us. That will be 1.805. Now that we have bar 3 as a characteristic, so when it comes to the normal, the bar 3 will move the decimal 3 places to the back. So we have it 1, 2, 3, and so the decimal will come here. So we have 0, 0. So the answer here will be 0.001805. To 3 significant figures, the answer will be 0.00181. Alright, so we have to solve this question. 0.81 multiplied by 10 raised to the power minus 5 over 2.25 times 10 raised to the power 7. Everything in square roots, then put everything again into the power of 3. So we have to solve these questions without using the logarithm table A and also using the logarithm table. 0.81 multiplied by 10 raised to the power minus 5 over 2.25 times 10 raised to the power 7. Everything in square roots, then put everything again into the power of 3. So we have to solve these questions without using the logarithm table A and also using the logarithm table. The essence of this is to compare our answers. Alright, so let's go without table. So we have 0.81 times 10 raised to the power minus 5. First, we can simplify this such that 81 is a perfect square. So we can move it 2 places forward, and when we move it forward like that, it becomes 81 times 10 raised to the power minus 2 times 10 raised to the power minus 5. Minus 2 here because we moved the 2 places forward. And then we have 2.25 times 10 raised to the power 7. So this as well can move forward such that we have 225, which is a perfect number, a perfect square. So that will be 225 times 10 raised to the power minus 2 and times 10 raised to the power 7. We bring this together and that would give 81 times 10 raised to the power minus 2. We have a multiplication sign here, and with that we have minus 2 and minus 5. Obeying the law of indices, the multiplication becomes plus minus 5 over 225 times 10 raised to the power minus 2. Here also we have plus times becoming plus 7, and so we shall have 81 over 225 times minus 2 plus minus 5. So plus times minus is minus. So we have minus 2 minus 5, and that gives 10 raised to the power minus 7. And this is 10 raised to the power minus 2 plus 7, and that gives 5. So these two can also combine. So we have 81 over 225 times 10 raised to the power minus 7. Here we have divided by 10 raised to the power 5. This division, obeying the rule of indices, the division will turn to minus, so we have minus 5 over here. 81 over 225 multiplied by 10 raised to the power minus 7 minus 5, and that gives minus 12. And don't forget that we have all these inside square roots, and so the square root of 81 here is 9, square root of 225 is 15. Then obeying the law of indices, square root turns to 1 over 2, so it's multiplying minus 12, so it is the square root. Now the square root has already applied to 81 over 225, but yet to apply to 10 to the power minus 12, and so that's what is happening over here. So we have 9 over 15 multiplied by 10, so 2 here 1, 2 here 6, so we have minus 6, so 10 raised to the power minus 6. 9 divided by 15, that gives us 0.6 times 10 raised to the power minus 6. So to the standard form, we'll have 6 times 10 raised to the power minus 7, because the decimal has moved 1 place forward, and that 1 place forward is minus 1. So minus 1 minus 6, that gives minus 7. Then everything to the power of 3. So 6 raised to the power 3, and that gives 216. And then 10 raised to the power minus 7 times 3. That's 216 times 10 raised to the power minus 21. Now, having 216, we need to change to standard form. So to the standard form, we move it 2 places to this place. So we have 2.16 times 10 raised power 2 times 10 raised power minus 21. Obeying the law of indices now, we have 2 and then this is plus minus 21. So our final answer is 2.16 times 10 raised power minus 19. So this is this answer without using the table. So now I want to solve this same question using the logarithm table. We have our number and we have our log. We draw table. So we have 0.81 times 10 raised power minus 5. Before we proceed, we need to change this to the standard form. So we have 0.81. When we move it one place forward, so this is minus 1. So minus 1 and minus 5, and that gives us minus 6. So our characteristic here is minus 6 points. Then we'll check 81 under 0 in our logarithm table, and that gives us 9085. Then we'll look for 2.25 times 10 raised power 7. This is already in the standard form. And so this 7 is the characteristic. So we place 7 points here. And we have 22 under 5 is what we are going to check in the logarithm table. So 22 under 5 gives 3522. Here we have it as division. So division takes negative on the logarithm column. 5 minus 2 gives 3. 8 minus 2 gives 6. 0 minus 5, impossible, so we borrow 1 from here. 10 minus 5 is 5. 8 minus 3 is 5. Here we have bar 6. So if you have bar 6 minus 7, minus 6 minus 7 is minus 13. So we have it as bar 13 here. So we've simplified the first aspect, which is 0.81 times 10 raised to power minus 5 over 2.25 times 10 raised to power 7. The other aspect now asks us to find the square root of all this. So the square root of all that will be divided by 2 under the logarithm table. But we can't find the division straight away because we have it as bar 13. So we'll change it to a number that can be easily divided by 2. And that will be bar 14 plus 1.5563 divided by 2. And that gives us bar 7.7. That's 2 into 15. Now that's 7. 2 times 7 is 14. 2 times 8 is 16. And 1. Alright. So we've found the square root of all these expressions. So we come over here. We have our number and log. So the next thing is for us to raise it to the power of 3. So we'll have everything to the power of 3. And when we have it to the power of 3, that means we have to multiply by 3. When we multiply by 3, that will be 3, 4, 3, 3. We have 2 here. 3 times minus 7 is minus 21. We have minus 21. And we have 2 that we've carried here. So minus 21 plus 2, that gives us minus 19. And that's synonymous to bar 19. We'll now check the anti-log table. That's 0.33 under 4 difference 3, and that gives 2.159. Then we have our bar 19, so we'll put it there as 10 raised to power minus 19. If we are to get our answer to 2 decimal places, so that will be 2.16 times 10 raised to power minus 19, which is exactly what we got when we solved this question without the table. Thank you very much for being part of the class.